Many of us remember a time when the word German stood for industrial might and cold, calculated efficiency. In the early days of World War II, the German Luftwaffe seemed unstoppable, flying sleek, powerful fighters and bombers, all engineered from the most advanced alloys and light metals that Europe could produce. Their industrial base was vast, and their engineers believed absolutely in the superiority of their steel and aluminum machines. This gave them an overwhelming confidence, a sense of technological destiny that allowed them to look down their noses at almost everything the Allies were attempting. If you ask many veterans, that arrogance was as much a weapon as their Messerschmitts. Now, imagine the sight when British designers, specifically from de Havilland, proposed a key weapon in the air war that wasn't built from a modern, sturdy metal. It was built from wood. They were proposing a mainline front-rank combat aircraft to take on the Wehrmacht using little more than plywood and balsa. This wasn't some training biplane or a glider. This was meant to be a high-speed, high-altitude tactical machine. Many viewers might think this sounds like something out of a desperate backyard shed project, not a serious military proposal. Therefore, this radical proposal was immediately met with skepticism, not just by the Germans, but by the British Air Ministry itself. Why? Because the prevailing wisdom of the era insisted that only metal could provide the necessary strength and speed for a modern bomber. But history, as always, had a surprise waiting, and that surprise was driven by a quieter kind of genius, one that saw opportunity where others saw only scrap lumber. The sheer disbelief when the Germans first saw or heard about this wooden wonder, the Mosquito, was palpable. Hermann Göring, the powerful head of the Luftwaffe, reportedly scoffed at the idea. Göring, a man who believed only the biggest, flashiest aircraft could win the war, thought the British must be truly bankrupt of materials to resort to building a bomber out of sticks and glue. This was a colossal failure of imagination, but also a failure of their fundamental doctrine. The Mosquito, initially conceived as an unarmed high-speed bomber, was designed to be so fast that it didn't need defensive guns or heavy armor. It was an audacious approach that flew completely in the face of the German idea of a heavy, protected bomber. Think of it this way. The German philosophy was to build a mighty battleship. The British decided to build a speedboat. Why bother with heavy armor when nothing can catch you? But when the Germans finally managed to intercept a Mosquito, their astonishment turned to a profound, deep anger. They simply could not believe that a cheap wooden plane could outrun their most modern fighters and, worse, deliver payloads exactly where they weren't expected. The Mosquito could cruise at speeds above 400 miles per hour at 30,000 feet, a terrifying stat in 1941. That speed and altitude were the secret sauce, and the wooden construction was the key to making it happen. The core of this unbelievable success wasn't the lumber yard, it was the engineering solution hidden within the wood. The British utilized a method called monocoque construction, which means the skin and frame of the aircraft worked together to carry the load, relying on the inherent strength of the materials, much like a well-made wooden canoe or a classic racing car body. The genius here was the material density and the adhesive. The Mosquito used a sandwich of light balsa wood layered between two sheets of birch plywood, all held together by a special casein glue that was remarkably strong. This composite structure yielded an extraordinary strength-to-weight ratio that traditional metal construction couldn't touch at the time. This meant the plane was lighter, therefore faster, and more maneuverable than its heavier aluminum counterparts. If you consider how many American boys flew in metal aircraft that were vulnerable to flak, the relative resilience of the wooden airframe was a huge insight. A metal skin, if punctured by a cannon shell, can tear like a sheet of paper, leading to catastrophic failure. However, the wood and glue composite tended to splinter and absorb energy, which contained the damage and allowed the plane to keep flying with surprisingly serious holes. This unexpected toughness became legendary among the RAF pilots, who realized their soft plane was actually deceptively tough. The Mosquito's early successes weren't just about tactical victories, they were a material revelation that changed the entire approach to air combat. By choosing wood, de Havilland bypassed the crippling wartime shortage of aluminum, which was desperately needed for other critical aircraft, like Spitfires and Hurricanes. This resourcefulness was a huge strategic advantage for the Allies. The simple fact is that the Mosquito was often 30 to 40 miles per hour faster than its contemporary metal bombers. This sheer performance advantage gave its crews a decisive edge in escape and evasion, drastically lowering crew losses, a reward that every pilot and every parent understood implicitly. This single plane became a living example of the idea that less is often more, provided you understand physics better than your enemy. This unprecedented performance immediately created a new problem for the Axis powers. How do you stop a ghost that you can barely see on radar and can't catch once you do? And therefore, the successful formula of the lightweight wood-based design became a kind of subconscious lesson for Allied strategists. It wasn't just a British plane that proved wood worked. It was a fundamental truth of engineering that would eventually, and surprisingly, find its way into the most vital, high-stakes American missions of the European Air War, setting the stage for the dramatic Ploesti raids that many of us remember so well. We continue our story deep inside the High Command, where the prevailing doctrine of the heavy bomber was gospel. They believed that to survive the brutal gauntlet of anti-aircraft fire in enemy fighters, a bomber had to be a flying fortress, heavily armored, bristling with machine guns, and able to absorb punishment. Many of you who followed the war know this mindset well. Think of the mighty American B-17 Flying Fortress, a marvel of engineering, built to take a beating and keep the crew alive. But there was a critical flaw in this thinking that the Germans, and initially even the Allies, failed to see. The problem of speed was turning traditional heavy bombers into sitting ducks. While they were certainly tough, every additional pound of armor and every turret packed with ammunition dragged the plane down, making it slower and less agile. The moment a heavy bomber entered hostile airspace, it became a tragic equation of interception. For the Germans, their metal bombers, like the Heinkel H-111, were relatively easy targets for RAF fighters due to their reliance on weight over velocity. Therefore, the moment the Mosquito appeared, it posed an existential question to this entire doctrine. Its designers, led by Geoffrey de Havilland, looked at the heavy bomber philosophy and decided to invert it. They argued, why build a bomber to survive an attack when you can build one that can't be caught? This wasn't just a design choice, it was a profound psychological and strategic shift. This was a direct, simple response to a question many veterans of the early war were asking. How do you get past the enemy before they even know you're coming? This speed difference meant the margin for error for the pilots was massive. A Mosquito crew, if intercepted, had a simple, high-percentage escape plan. Open the throttle and climb. This was the ultimate get-out-of-jail-free card, a luxury denied to the slow-moving metal behemoths that had to rely on cumbersome defensive maneuvers and sheer luck. This wasn't just about saving fuel or time. It was a matter of life and death for every young man flying across the English Channel. It was a secret asset that immediately reduced the drop-off in aircrew retention, a critical reward that history often overlooks.
The answer to the speed problem was the revolutionary structure of the Mosquito. The choice of wood wasn't an act of desperation, but a deliberate technical payoff that leveraged the material's unique properties. As we discussed, the plane was constructed using a balsa core sandwiched between birch plywood, a composite material that offered incredible performance. The lightness of the wood was the key to this triumph over aluminum. Aluminum alloys, while strong, are dense and require internal structural supports, ribs and stringers, adding significant non-productive weight. The wooden monocoque construction, however, distributed stress throughout the entire airframe's skin. This meant the Mosquito's structure was inherently lighter and simpler, directly translating into the velocity that rendered German defenses obsolete. This weight saving was the first and most immediate reward of the design. Furthermore, this seemingly primitive material offered a surprising benefit in the radio detection war. Many viewers tell us that the wooden structure provided a significantly smaller radar signature than an equivalent metal aircraft. The wooden fuselage and wings reflected far less of the high-frequency German radar waves. This wasn't stealth technology as we know it today, but it was an unexpected reward for the design team, making the Mosquito an unseen threat that literally vanished into the electromagnetic noise. The result was a machine that could carry a 4,000-pound bomb load, the same as a B-17, but could fly faster than any German fighter in service at the time of its introduction. But the German engineers, stuck in the mindset of metal and armor, were slow to grasp that the lack of guns and armor wasn't a weakness, it was the ultimate strength. They were trying to solve the problem of bomber vulnerability by adding more steel, therefore ensuring that their planes would remain slow, cumbersome, and increasingly vulnerable to the ever-improving Allied fighters. They were fixing the symptom, not the cause. The operational debut of the Mosquito immediately raised a curiosity among RAF planners. What is the true value of tactical surprise when sustained over time? Because the Mosquito was not only fast but also difficult to detect, the RAF was suddenly able to conduct missions that were previously unthinkable, gaining an enormous intelligence advantage. The Mosquito became the ultimate reconnaissance tool. Unlike previous spy planes that relied on brute speed or heavy fighter escorts, the Mosquito flew alone, often completing photographic survey missions deep inside the Reich and returning with vital, up-to-the-minute data. The crews were essentially flying in a cone of silence, where the German defenses were scrambling based on delayed or inaccurate radar reports. This provided a continuous stream of intelligence, offering an unparalleled reward in strategic planning. The speed and operational secrecy allowed the RAF to perform precision bombing with devastating effect. One famous micro-story that many remember involves the Gestapo headquarters in Oslo, Norway. The Mosquitoes flew a highly risky, low-level attack in 1942, dropping bombs directly onto the building to destroy key files. This mission, which risked disaster, demonstrated that the Mosquito wasn't just a fast bomber, it was a precision instrument capable of surgically striking vital targets. Therefore, the RAF learned that the tactical surprise offered by the Mosquito allowed them to dictate the terms of engagement and select targets based on value, not simply survivability. This wasn't just about blowing things up, but about the psychological impact. The ability of the Mosquito to show up unannounced and leave without a scratch, time after time, deeply demoralized the German defenses. The enemy soldiers never knew where the next strike would come from or when. Because of this lack of detection, the Mosquito earned the grim nickname, the Phantom of the Western Front, a reward of fear and respect that few other Allied aircraft achieved. The most significant strategic surprise came when the German Luftwaffe realized the shocking truth. Their best fighter planes were too slow to catch the Mosquito. They had invested their engineering skill and scarce resources into fighters that were heavy, well-armed, and built for dogfights, but not for intercepting a high-flying wooden ghost. This realization delivered a fatal blow to their air defense strategy. The Messerschmitt Me-410, one of the Luftwaffe's later twin-engine heavy fighters, was specifically designed to take down the Mosquito. But history suggests that the Me-410, despite its powerful armament, still struggled with the Mosquito's superior altitude performance and cruising speed. It was a costly and disheartening reward for German engineers who had bet on the wrong horse. Many of us who remember the war understand that this realization must have been a devastating blow to the morale of the pilots, who were effectively sent up on futile chase missions. The Mosquito's speed advantage forced the Germans into a desperate, resource-draining strategic shift. They were compelled to divert some of their jet fighter development, namely the Me-262, to try and catch the Mosquito, which delayed the deployment of a truly revolutionary weapon. This strategic sacrifice was a massive reward for the Allied war effort, but the necessity of countering the wooden wonder also meant the German High Command had to grudgingly acknowledge the core design principle they had initially ridiculed. Therefore, the success of the Mosquito didn't just win battles, it won arguments about engineering principles, proving that lightness, speed, and efficiency were sometimes far superior to brute force and heavy armor. This profound, undeniable fact that wood, glue, and genius could beat steel and arrogance set the stage for a critical moment where the American strategic bombing forces would be compelled to adopt a similar wooden design philosophy for their most critical mission, the Ploesti oil fields, that many of you know were the very lifeblood of the German war machine. The incredible success of the Mosquito, while a British victory, immediately created a new, pressing problem for the entire Allied cause, particularly for the United States. You see, the war wasn't just being fought in the skies over Europe. It was being fought in the terrifying cold waters of the Atlantic Ocean. The Mosquito had proven the value of speed and material science in aerial combat. But on the high seas, an older, deadlier foe was winning the war, the German U-boat. The U-boat scourge was the most immediate, life-threatening problem the Allies faced in 1942. These German submarines were sinking Allied merchant ships faster than they could be replaced. This maritime crisis directly threatened the supply lines that were feeding Britain and enabling the buildup for the eventual invasion of Europe. It was an agonizing situation where success in the air didn't mean success in the ocean. This required a different kind of aerial asset, a patrol bomber with massive range and endurance, capable of flying hundreds of miles out into the Atlantic and staying on station for hours to hunt down the elusive U-boats.
What the existing American patrol aircraft were too slow and too short-legged. The consolidated B-24 Liberator, while capable, was designed primarily as a heavy bomber and still carried the baggage of traditional metal construction, which meant higher fuel consumption and reduced range for the task at hand. The Air Ministry understood that just flying an existing plane further wasn't the reward. They needed a completely new design philosophy to effectively push back the U-boats and secure the Atlantic. This problem of needing an aircraft that was both long-range and fuel-efficient, yet still robust, was the strategic bottleneck of the early war. Therefore, the U.S. needed to find a way to quickly develop an aircraft that could patrol over a vast, featureless ocean, withstand the rigors of weather, and carry enough ordnance to actually sink a sub. This critical need for maximum operational range with minimal structural weight forced American designers to look beyond their own conventional wisdom and eventually consider the very design principles that had made the Mosquito a ghost over Europe. The requirement for a long-range maritime patrol aircraft immediately kicked off a heated twin-engine design debate within the U.S. military and aircraft industry. American ingenuity wasn't lacking, but it was often constrained by established manufacturing techniques and a preference for all-metal construction. They were trying to achieve range by simply adding more fuel tanks, which added weight, defeating the purpose. The challenge wasn't just to build a plane, but to build one that maximized efficiency. The Mosquito's lesson, though subtle, was clear. Weight is the enemy of performance, speed, and endurance. The initial American designs favored robust metal frames, believing this was the only way to endure the heavy stresses of prolonged flight and open ocean landings. This conventional approach, however, required powerful engines that consumed huge amounts of fuel, ironically reducing the very range they sought. Therefore, the realization dawned that to hit the necessary range, they had to shed weight dramatically, and the only proven way to do that while maintaining structural integrity was to explore non-traditional materials, exactly as de Havilland had done. This intellectual pivot was a powerful reward for those designers who are already arguing for lighter-weight solutions. The debate shifted from how much metal to what materials, a direct result of the Mosquito's quiet success. The U.S. Navy and the Army Air Force, though slow to change, began to seriously analyze the Mosquito's construction logs. They realized that the weight savings offered by the wood composite method were exponential, far outpacing the weight saved by optimizing metal parts. Many experts began to see that the British weren't just conserving aluminum, they had found a superior way to construct a wing and fuselage for a specific performance goal. The shift wasn't just about building a plane, it was about adopting a new mindset of resourcefulness, a lesson the greatest generation took to heart in all aspects of wartime production. Now, we come to the part of the story that often sparks a curiosity, the missing link that explains why Washington, with its fierce pride in domestic manufacturing, suddenly started taking design cues from London's wooden wonder. This wasn't a formal transfer of technology, it was a strategic, almost clandestine adoption driven by wartime necessity and a grudging respect for proven results. The mystery wasn't about the plans, it was about the proof of concept. American officials visiting Britain were given demonstrations of the Mosquito's performance, seeing its raw speed and payload capacity with their own eyes. They saw a plane that was built not by a massive assembly line, but by small furniture and piano factories, easily bypassing the congested major airframe plants. This was the true reward, decentralized, rapid production. But the true catalyst lay in the realization that the wood composite approach could be used to quickly modify and extend existing American airframes for specific roles, like that pressing U-boat patrol need. They realized they didn't have to build an entirely new Mosquito. They could integrate the lightweight philosophy into their own aircraft where metal shortages were creating bottlenecks. This became the key to unlocking the problem. Therefore, the Mosquito served as the ultimate psychological tool. Its existence validated the use of unconventional materials and forced the powerful aluminum lobby in the U.S. to step aside for specific, critical projects. The American military didn't need to copy the entire plane, but they needed to copy the principles of high-strength, low-weight composite construction. This adoption wasn't publicized widely. It was an internal secret, a quiet acknowledgement that a little bit of British ingenuity had solved a massive industrial problem. The ultimate payoff of this cross-pollination wasn't a bomber. It was the creation of the forgotten cousins, the American wooden gliders and cargo aircraft that played a crucial, though often overlooked, role in the war. The United States leveraged the Mosquito's lesson in composite materials to quickly produce the massive Curtiss C-46 Commando and the crucial cargo gliders used in major airborne operations like the invasion of Normandy.
The cargo gliders, such as the Waco CG-4A, were massive planes built almost entirely of fabric and wood. They were cheap to build, utilized a non-strategic material, and could be produced quickly by non-aircraft manufacturers, fulfilling the promise of de Havilland's decentralized production model. This was the practical reward of Washington finally listening to London. This resourcefulness allowed the U.S. to rapidly deploy troops and equipment where traditional metal planes couldn't land, providing a necessary, powerful component to the D-Day landings and other major offensives. Many veterans remember these gliders, often nicknamed the Flying Coffins, which required incredible bravery from their pilots. However, their ability to deliver vital troops and supplies silently behind enemy lines was a strategic advantage made possible by the very wood construction philosophy the Nazis had initially mocked. Therefore, the Mosquito's legacy evolved from a fast, tactical bomber into a domino effect that fundamentally changed American logistics and design for specific high-risk, high-reward missions. This journey, from the U-boat crisis to the wooden gliders of Normandy, proves that the simple fix that bypasses conventional roadblocks can often be the most profound and revolutionary advance in wartime. This lesson in low-tech brilliance was the true, enduring reward of the Mosquito design. We arrive now at one of the most critical and deadly missions of the European theater, the assault on the Ploesti oil refineries in Romania. For many of us who lived through or studied the war, the name Ploesti conjures images of unmitigated hell. The Allies knew that oil was the bloodline of the German war machine. Without fuel, the panzer divisions couldn't move, and the Luftwaffe couldn't fly. Therefore, the destruction of the Ploesti refineries was deemed essential, a reward worth any cost. But the price of that reward was staggering. The sheer difficulty and the resulting casualties made Ploesti a death sentence for the young airmen in 1943. Why? The problem wasn't just the distance. It was a staggering 2,500-mile round trip from North Africa, but the defenses. The Germans were fully aware of Ploesti's strategic importance. They had turned the complex into one of the most heavily defended spots on Earth. The defenses included thousands of anti-aircraft guns, camouflaged artillery batteries, and multiple rings of fighter protection. The operation, codenamed Tidal Wave, was initially carried out by low-flying B-24 Liberators in a daylight raid designed for maximum surprise and saturation. This was done in the belief that the heavier metal bombers were tough enough to survive. This was common wisdom, but it led to a tragic outcome. The lack of stealth, combined with the target's pre-existing layered defense, resulted in horrific losses: 53 aircraft destroyed and 660 airmen killed or captured. That's a staggering price to pay for a single mission. The sheer scale of that drop-off was a stark, painful lesson that the heavy all-metal bomber strategy, relying on muscle and armor, simply wasn't the right tool for every job, especially not one this critical. Therefore, the military was forced to search for a new, unconventional approach that could bypass the defenses rather than try to batter through them. The survival of the strategic bombing campaign depended on it. The devastating failure of the daylight raid on Ploesti immediately sparked a consuming curiosity within Allied strategists. How could they hit the target again, but this time avoid detection entirely? The high value of the oil meant the risk had to be repeated, but the methods had to be fundamentally different. The answer lay in the night and the need for precision. The problem was that the large, slow formations of heavy bombers couldn't navigate accurately at night, and they certainly couldn't sneak past the defenses. This is where the subtle but yet powerful influence of the Mosquito's success finally cemented itself in American doctrine. They needed something fast, silent, and invisible to act as a precision guide, a pathfinder. This shift from brute force to surgical finesse was the critical reward that the Ploesti disaster forced upon them. What made the night-flying pathfinders truly unique was their adaptability. Since the goal was precision targeting at night, the U.S. Army Air Force decided to use smaller, more efficient aircraft, often stripping them down for maximum speed and range. Many viewers tell us that the P-38 Lightning fighter was even adapted for this role, demonstrating the urgency of the shift. This aircraft, while not wooden, embodied the Mosquito spirit, faster than the enemy, focused on mission efficiency, not defensive armament. The key reward of this shift was not just about finding the target, but about marking the target for the main force. The Pathfinders often utilized new radar and navigation aids to precisely locate the refineries under the cover of darkness and mark them with flares and incendiaries. This reduced the risk for the main bomber force, allowing them to fly higher and slightly faster and dropping their bombs with far greater accuracy. The strategy proved that by integrating speed and surprise into the American approach, they could achieve their objective with far less bloodshed. Despite the direct use of metal aircraft like the P-38 as pathfinders, the unspoken lesson of the Mosquito's wooden advantage was the underlying technical catalyst for this entire strategic shift. The Mosquito had already proven beyond a shadow of a doubt that a high-speed, structurally sound aircraft could be achieved using lightweight, non-metallic materials.
But why was the wooden advantage so important here, even if the Ploesti Pathfinders weren't made of wood? Because the Mosquito had already fought and won the argument for lightweight design and high-velocity evasion. The P-38 was fast, but it still used aluminum, which was a strategic material. The success of the Mosquito showed that if speed and surprise were the goals, sacrificing armor was logical. The true reward of the wooden advantage was the validation of velocity and structural efficiency over armor. When the American strategists analyzed the Ploesti failure, they realized that the B-24s were simply too slow to escape the ground fire and fighters once the element of surprise was lost. They learned the Mosquito's most important secret: speed is survival. This wasn't a philosophical choice anymore. It was empirical data proving the value of lightweight speed in penetrating dense defenses. Therefore, the Mosquito's quiet victory was the precursor to the Pathfinder concept. It provided the necessary evidence that a plane designed for avoidance rather than endurance could be far more effective in high-risk environments. This realization enabled the U.S. to commit to the use of highly specialized, stripped-down aircraft for this role. It was a perfect demonstration of adapting proven ingenuity to an entirely new problem, ultimately saving countless lives by changing the equation of the mission. The ultimate and most direct payoff of the wooden design philosophy and the final twist in this tale of fur and fate came not in the Pathfinder planes themselves, but in the silent sleds that carried the strike. This brings us back to the forgotten cousins, the American wooden gliders. While the Mosquito was designed for speed, the American gliders were designed for pure silence and capacity. They were massive structures built from wood and canvas, designed to carry heavy equipment and fully armed troops deep behind enemy lines. The very existence of these gliders and their successful mass production was a direct reward of the design lessons learned from the Mosquito's wood composite structure, lightweight, strong, and made from non-strategic materials. Therefore, the most valuable oil target of the war, Ploesti, was eventually hit using a strategy rooted in a material the enemy had scorned. While the Mosquito and P-38 were part of the aerial tactics, the philosophy of using lightweight, non-metal structures for specialized, high-risk missions was the enduring legacy. This demonstrated the profound wisdom of the simple fix. Resourcefulness and unconventional thinking can defeat technological arrogance. The Mosquito proved that wood could fly fast and evade. The gliders proved that wood could fly silently and carry immense loads. This was the defining characteristic of the greatest generation's industrial war, the ability to adapt, improvise, and use whatever materials were available to solve the problem. Therefore, the story of the Mosquito and the Ploesti raid is not just about planes and oil, but about the enduring reward of ingenuity, humility, and the quiet triumph of common sense over rigid dogma. The Mosquito was arguably the most successful, most versatile aircraft of its kind in World War II, a true testament to British ingenuity and the simplicity of its wooden design. Many veterans saw it as a marvel, a plane that consistently delivered missions others couldn't touch. This leads to a profound final problem that history compels us to ask. Why did the idea of the wooden wonder virtually disappear after the war, making the Mosquito a singular, historic anomaly? For many of us who remember the spirit of that era, it seems counterintuitive that such a successful, fast, and resource-efficient design wouldn't immediately become the template for the future. The plane was easy to repair, bypassed aluminum shortages, and proved that decentralized production, using furniture factories instead of massive industrial complexes, could work. Yet the moment the war ended and the necessity of wartime scarcity was lifted, aircraft design overwhelmingly pivoted back to metal and then quickly toward the jet engine. The core issue was a complex collision of economics, physics, and manufacturing logistics that the end of the war created. During the war, the Mosquito's plywood structure was a feature because it avoided the scarce aluminum. But as soon as aluminum supplies normalized, the material became a manufacturing obstacle. Metal stamping, riveting, and assembly lent itself more readily to the mass production, standardized precision, and ease of modification required for the peacetime aviation industry. But the move back to metal also solved a problem inherent to wood itself: environmental vulnerability. The Mosquito's glued joints and composite skin were sensitive to extreme climatic changes, humidity, and heat, causing swelling and warping over time. Though this could be managed during a wartime production push, it became a long-term maintenance headache for commercial and permanent military fleets. Therefore, the immediate reward of using readily available wood faded in the face of the long-term reliability and lower maintenance cost offered by the readily available post-war aluminum. The ultimate and most direct payoff of the wooden design philosophy, though it meant the end of wooden aircraft dominance, was its influence on the post-war design shifts and the rapid embrace of the jet age transition. The Mosquito didn't just teach the Allies how to build a good propeller plane, it provided the philosophical foundation for the age of velocity that followed. The Mosquito's emphasis on speed as the primary defense was the philosophical precursor to the jet fighter. It proved that maximum velocity was the ultimate guarantor of mission success and crew survival, making the transition to jet propulsion an absolute, undeniable necessity. This realization became the single most important design reward carried forward from the piston engine era. The focus shifted entirely to the newly developed jet engines, which demanded rigid, structurally sound materials capable of withstanding unprecedented heat and stress. Aluminum and steel, despite their earlier shortcomings at high speeds, were the only materials capable of handling the demands of early jet travel. This forced the industry to rapidly abandon wood, not because it was inherently bad, but because it could not meet the demands of the new power source. Therefore, the industry was forced to develop completely new, stronger aluminum alloys and advanced manufacturing techniques like integral machining that made the high-speed all-metal jet a reality. Think of the sudden transition from the Mustang to the Sabre jet. This was the ultimate realization of the Mosquito's speed-first philosophy. The Mosquito's success allowed designers to confidently shed the need for heavy defensive armament and embrace velocity-dependent strategic thinking, setting the stage for the next 70 years of air combat. For many of us, the story of the Mosquito, the wooden gliders, and the engineers who built them strikes a deep nostalgia beat. It reminds us of a time when resourcefulness wasn't a choice, it was simply how things were done. This era taught us an invaluable lesson. The most elegant solution is often the simplest and most resourceful. We look back at this period and marvel at what that generation accomplished with so little. They didn't have unlimited funds or endless resources. They had constraints, and they let those constraints drive innovation. The Mosquito wasn't built from wood because it was easy. It was built from wood because the engineers refused to accept a resource shortage become a mission failure. This refusal to accept defeat became a powerful reward in and of itself. But this sense of ingenuity wasn't just about aviation. It reflected a broader cultural spirit that defined the time. Whether it was victory gardens or scrap metal drives, the emphasis was on maximizing what you had. The Mosquito is the ultimate representation of wartime efficiency, forcing a powerful yet simple question. What valuable resources are we overlooking right now in our own lives because we're too focused on the conventional right answer? Therefore, the Mosquito's existence serves as a powerful metaphor for the idea that ingenuity flourishes under pressure. It teaches us to respect the foundational principles of engineering, like the strength-to-weight ratio, over the perceived glamour of the latest technology. This sense of making do and innovating with simple materials is a tradition that many viewers tell us needs to be remembered and honored. Would you like me to share one of those simple yet powerful engineering principles next? The enduring wisdom of experience derived from the Mosquito and its wooden cousins offers simple lessons still relevant today, whether you're running a business or simply fixing something around the house. These are the practical, powerful takeaways from the ultimate high-stakes engineering challenge.
Thank you for watching. If you enjoyed our efforts to create this video, please take a moment to subscribe. We'll see you in the next chapter of Forgotten History.